Hello everyone, welcome to the third lab, which is on simulation of dynamic systems. I think this will be a lengthy video, but bear with me. Okay, so here are some learning objectives. You should read those. And the first thing we're going to do is learn how to get information about a Simulink model that we have. So to do this, we're going to provide the syntax here. We're going to find the sizes, the initial conditions, and the states for a given model. So what are sizes? Sizes is an array of integers that tells you information about the model. Each index of the array is dedicated to some aspect of the model. For example, the first index tells you how many states there are in the model. If you remember from my last office hours, we did a simple spring mass system which had two states, and our states array therefore had two entries, x and x dot. Our first example is simple. We will run this line here to provide us with the sizes, initial conditions, and states for the forced simple pendulum model. You should open up this model before you run and make sure that it is in your directory, so that way MATLAB can access it when you want to run this line. And you can do that on the top of MATLAB. You should have some file path, and you can select which file path you want to do. Make sure that you see this file here. Okay, so if you run this, here's our sizes array. So we have 2, 0, 0, 0, 0, and then a 1. So as we said, the first index is the amount of states, and as we know, there's two states in a pendulum, right? It's just 1 degree of freedom, and the equation of motion, highest order derivative is 2, so we're going to have x and x dot as our states. And then 1 down here tells us if the Simulink model is continuous or discrete, and 1 means it is continuous. Here's the initial conditions that are entered into those integrator blocks. And the states are our position and velocity, just as we expect. Moving on to slide 7. Now we know how to get information about a Simulink model, but we can also run Simulink files from a MATLAB script or from a command window. To do this, we use the sim function. All we need to do is input the model name, the simulation time, and any options we want to run with. Here, if we put look at this table here. If we put the number 1 into the time span input, or sorry, if we put one input, one integer into the time span, so just like some number here, then the MATLAB tells Simulink to run it for that amount of time. So 4 seconds, it'll run from 0 to 4 seconds. If we put two numbers, then the simulation will run from the first number to the next number, and our output times, if we have, say, an array of times, then it will simulate at each of these times. For example, 0 to 4 in increments of 1 millisecond. If you input that array there, it'll run at those times. For the options, here is a bunch of options you can pick from. Here we're going to use relative tolerance with a value of 1 times 10 to the minus 4. And we're going to use the ODE for solver. So this is our options that we can get. Notice we're using SimSet to pick our options. SimSet, the option, and the selection within the option. Here's another option, the solver type, and our selection within the option ODE for. Okay, slide 9. Here's some more options. And slide 10. So our second example will have us run the forced simple pendulum, and we want to find position and velocity. So here's the code that will provide position and velocity. Note that if you're copying and pasting the code, which you should all be doing, run the code, make sure you understand it. You might need to redo all of the apostrophes. MATLAB might give you error, doesn't recognize it when you copy and paste it over. Just redo them. I had to do that. You might also need to add underscores, so Here you see for simple pendulum. I might copy and paste without these.